And the next step in our progression is to do something called factoring using the GCF. I like to call it undistributing. And so the difference between the previous set of videos and this is that now we have pluses and minuses that will be given to us between our terms. And so you won't look at them as monomials, but rather as a group of polynomials. And so when I look at this first example, it says 21x squared minus 35x. The question that I have to ask myself is, what is the largest term, or what's the largest value that could divide both of these nicely? And when you look at 21 and negative 35, hopefully most of these numbers, they just pop into your head. For me, when I look at that, immediately it's just screaming at me. 7 would divide 21 and 35. So what I'll do is I'll pull out a 7. And then in terms of the variables, I see that they each have an x to offer. So I pull out an x. And I say pull out because it's something that has to be distributed. So this would be 7x, and then I have to ask myself, 7 times what produces 21? 3. X times what produces x squared? X. 7 times what produces negative 35? Negative 5, and I already have the x there. And so what's crucial is when you look at this, you have to understand the mechanics of your undistributing. This outside here, what you pull out would be known as your GCF, and then what's inside your parentheses would be something that is relatively prime. And from the last set of examples, I did give the vocabulary word. I don't know if you caught that or not, but something that is relatively prime means that these two things have a GCF of 1. These two items have to have a GCF of 1. So this was what was common among your original two terms. That's your greatest common factor. And what's left over would be relatively prime terms. And so this is an example of factoring using the distributive property, or using GCF. We'll do a second example, and we're just going to start all over. So we look at this, it says 24a squared b minus 40ab. And you have to think, well, what's the first number that would divide both 24 and 40? Now, I'm going to pretend like it's 2. Some of you are probably going to be screaming out there going, no, it's not 2, you can go bigger. Let's do like most of us would do. Maybe you don't see the big picture, and so you look at that and you're like, oh, well, 2 would divide that. And the same with the variables. I see that they each have at least an a and at least a b to offer. So I go 2ab. 2 times what produces 24? 12. And then a times what produces a squared? You need another a. B is already here, so you're in good shape. Minus 2 times what creates 40? 2 times 20. And I already have my ABs there. Now from what I said in the first example, the outside has to be your GCF, and what's left in your parentheses has to be relatively prime. Relatively prime means nothing else would divide both of the terms. So when I look at this, I have what I'm calling a GCF here, but when I look at the parentheses, I clearly see that these are both even, meaning I could have went bigger. I should have pulled more out. And so what else could I have pulled out? I could have started by pulling out a 4. Okay. Now, because I didn't see that, and this is one of the things that I want to show you before we get into this routine and think that we're always right with what we originally pull out. If you make a mistake and you don't go big enough, you don't have to start all over. You just have to pull out what's still left over and multiply this by that value. And what I mean is, do you see that 12 and 20 is still divisible by 2? So if I pull a 2 out, that 2 is going to come out and be multiplied with this. So 2 times 2 would be a 4ab. And now from here I can either say, let's go back to this, 4 times what is 24, or I could say that I'm pulling the 2 out of the 12, so 2 times what is 12. It would be the same result either way, which would be our 6a. And then in a similar way, I like going back to the original. 4 times what is 40? And you would say 10. And then when we look at this, we recognize that, well, wait a second, we still didn't go big enough, did we? Because this is still not relatively prime. There's still something that divides both of those. So that means I should actually go all the way back again and say, well, now I can pull another 2 out. If I pull another 2 out, it would be 8 AB. 8 times what is 24? It would be 3A. 8 times what is 40? 5. Now, I hope you don't do these problems like this, but it is important to know that if you make a mistake, you can just keep going with your work. It's not a big deal. You just want to make sure you get down to this last part where you have a GCF for your original two terms, and what's in the parentheses is relatively prime. Okay? Now, again, you're looking at that saying, well, boy, that was a lot of work. Well, hopefully you're smart enough that when you look at these and you get the experience that you go 24 and 40 have a GCF of 8. You don't want to have to go through this process of pulling something out and then pulling more out and then pulling more out because it's not very efficient. And so let's take a look at a third example, and hopefully from the get-go we'll be able to come up with what they have in common. And so on this one it says 15e cubed minus 25e squared plus 5e. Now you saw me kind of fix this last part there. When I look at all three of these, this is screaming at me that they all have a 5 to offer and they all have an e to offer. So I'm going to pull out a 5e. 5 times what is 15? 3. E times what is e cubed? E squared. 5 times what is negative 25? Negative 5. Now I need to get to an e squared. I pulled an e out, so e times what is e squared? E. And finally, and this is the one that sometimes catches kids, 5 times what is 5? You have to have a placeholder. If you have 3 terms here, in your parentheses you'll have 3 terms. It always has to be balanced. So up here at the first example, I had 2 terms. In my parentheses, I had 2 terms. Example 2, I had 2 terms. In my parentheses, I have 2 terms. Example 3, I started with 3 terms. I pulled out what I believe to be the GCF, which is 5e. I have to have 3 terms here. And so I'm going to put a 1 there as a placeholder because 5e times 1 produces 5e. That's always going to be balanced, always going to be matched. Now again, I look at this is the GCF, and then I look inside here. Is there something that I could divide all of these by other than the 1? And so the answer, of course, is no. That means that they are relatively prime. I am done factoring. I've undistributed.